Why are extrusion aluminium dies corrected? The core tooling component in extrusion is the die. The billet is pressed through it to get the desired shape of the product. Additional tooling is required to provide sufficient rigidity to the die against the pressure applied by the ram of the extrusion press. On the basis of the shape of the extruded profile, dies are generally classified into three types: solid, hollow, and semi-hollow. The solid profiles are usually extruded through a single-piece die, whereas the hollow shapes require a two-piece die set, known as cap and mandrel, to form the hollow profile. Semi-hollows are solid profiles without a fully enclosed cavity but need a cap and mandrel set. The correction of aluminium extrusion dies could be required due to many reasons, such as improper metal flow, dimensional variation, surface finish, improper interference with runout table. Many factors affect the running of a die at the press. These factors need to be considered when correcting extrusion dies: die temperature, billet temperature with respect to container temperature, taper billet heating, change of extrusion speed, press alignment and adjustment, deflection of die stack, rotating the die to change position. In addition, problems associated with the press can include the following: improper tool stack, flatness of the pressure ring, improper sealing of the die with the container liner, a washed-out container liner, worn-out dummy pads. Some of tools used in the daily work of any corrector are illustrated in this figure: measuring and control instruments, cutting tools for changing the shape of a die, hand metalworking files for adjusting the bearings of dies. Examples of improper metal flow through a solid die are shown in this figure. Correction of a solid die can require modification in the pocket, modification, the feeder plate, modification of the bearing length from the front or exit side of the die. The proper method of correction should be by using a milling machine, a flexible grinder, an old carbide tip method. The correction of a hollow die is very complex compared to that of a solid die. There are many variables associated with hollow dies, such as ports, depth of bridge, and the weld chamber cavity. The correction of hollow dies could be due to twist, angularity, split corners, a convex wall, a concave wall, an uneven wall. To correct the flow on a hollow die, examine the port first before working on the bearings. Ports control the volume of metal, which needs to be balanced in relation to the cross-sectional area of the extrusion that each port is feeding. Thank you for watching.